I want to take a look at number 51 on page 165. So 51, page 165. This is a horizontal projectile motion problem, so something is given an initial horizontal velocity and allowed to fall all at the same time. It says you accidentally throw your car keys off a cliff. I don't know how you do that, but whatever. Okay. So this cliff is 64 meters high. That's a long ways up. Okay. And you throw your car keys this way at 8 meters per second. Okay. We need to go ahead and establish positive directions. I usually choose up and right to be positive. So there's positive. This is X. This is Y. Okay. And we're just supposed to figure out how far from the base of the cliff, so we should look for the keys. Okay. So here's the base of my cliff. We throw the keys this way, of course they fall down, sort of like that, and we're supposed to figure out this distance, delta x. Okay? So whenever we do these problems, I'm going to split this up, and I'm going to have x and I'm going to have y, and we'll go through and figure out everything we know in both. So initial velocity in x, I know is 8 meters per second, because it says we throw the keys horizontally at 8 meters per second. The initial velocity in y, v naught y, is 0, because we didn't throw them up, we didn't throw them down, we just threw the keys horizontally. Initial position in x, actually let's do acceleration next. Acceleration equals, well in x it's 0 because gravity pulls down, so in y, acceleration in y is equal to negative 9.8 meters per second. Alright. Initial velocity, final velocity. I can't say anything about the final velocity in either one of these. I don't know enough information. I can say stuff about the final position, so we'll talk about initial position. Initial position for that is 0. It starts right here. Okay. Initial position in y is of course 64 meters. It started at the top of the cliff. Final position is what I really want to know, and final position in y is 0. It ends on the ground. Okay, t, don't know t, but if I can find t, we can solve this problem. Okay, because the times are the same. So I'm going to go ahead and work this one out. Okay, and I'm going to start in y and use the time I get in y in x. So over here, I know that final velocity equals initial velocity plus acceleration times time. Don't really need that one. Okay, I want, because I don't have a final velocity. At the second equation, it says y equals 1/2 at squared plus v naught t plus y naught. Okay. Well, I do know most of this information. It ends at 0. Half of negative 9.8 is negative 4.9. T squared plus 0, right? Its initial velocity in y is 0, plus 64. Okay? And so now I have 64 equals 4.9 t squared. You're thinking, where did that negative go? Well, I subtracted the 64 over and that became negative. So I had a negative on both sides, so they cancel out. So then I have 64 equals 4.9 t squared, and all I have to do is divide both sides by 4.9, divide by 4.9, and I get t squared equals 13. Square root both sides, and I get t equals 3.6 seconds. Alright. That is in y, but since the time is the same for both, I can take this 3.6 and put it here, and now I can solve everything I know in the y direction. Okay? So I want to know its change in position. I'm going to use the same equation. X, final position, equals 1/2 at squared plus v naught t plus y naught, but, or not y naught, x naught. Okay, but this time the acceleration is 0 and its initial position is 0, so those go away. So I have its final position equals 8 times 3.6, which is about, let's see, 648, 28.8 meters. Okay, so we should look about 28.8 meters from the cliff in order to find the keys. Okay, 52 is a very similar problem. If you can find time, then you can figure out everything else.